this. Mr. Smith claims that he's an 80% free throw shooter. Mr. Duncan, skeptical. He believes that he's less than 80%. Smith has decided to take another sample of 50 free throws to prove himself. Great, awesome. Okay, so this is all kind of review what we were doing last week. Write an appropriate hypothesis for the significance test. All right, let's go back. And we have the null and the alternative, right? So is this proportions or is this means? Proportions. How do you know it's proportions? It's a percent, so that means I'm going to use the P symbol on both of them, right? And what is he claiming he is? 80%. So that number stays the same on both, right? He claims he's 80, but the guy is skeptical. He thinks it's less than. So I could, since the alternative is less than, I could write my null as greater than or equal to, right? That helps when we're talking about errors to think it through like that. All right. Look, you did it. You did it. So P is equal to the percent of free throws made. All right. All right. Type 2 error. What in the world? Do y'all remember this at all? What do you remember about it?
The type 1 and type 2 is like the opposite kind of. So.
All right. There's start. Anything else?
Failed to reject.
Good. Yeah. Type 2 is when you failed to reject, but you messed it up, right? Both of them are mess ups, but which one is which? Type 2 is failed to reject because it has 2 in it. All right. So a type 2. So let's think here. Here's the alternative, or null and alternative. Type 2 means I failed to reject the null. That means I found evidence of the null, but it was the alternative that is true. So now just put it in words. It's exciting, I know. So we found evidence that, who is this, Smith, what, is less than an 80%, greater than 80%? What are we? We found evidence that Smith's free throw is 80% or more, but in reality, he is less than, or he shoots less than. All right, we got that? Okay, now, let's suppose that his true free throw percentage is actually 66%. That would mean the alternative is true, right? So we're going to enter all this information into an applet, and I'm going to show you something. Click to display type 2 error, show blue shaded region. All right, so just hang on for the ride here. You don't have to. Come on, go with me. It's not going to do it, is it? Let's see if I can do it on the screen here. Oh, what a good day. Lovely. Look how fancy that is. All right. So the null hypothesis we said was 80%, right? So the red curve over here represents the null hypothesis, what they claim. So is this test a two-sided, a one-sided? Like, is it less than, greater than, or a two-sided test? This is that tailed thing. Left-tailed, right-tailed, two-tailed. Think about our alternative hypothesis. Is it pointing one direction? Which way? Left. So it's less than, right? Okay, so we would shade on the left side. We want to display a type 2 error. And now we found that his real value is 0.66. So it's somewhere right there. Boop. All right. Sample size is 50. Type 1 error, remember that's alpha. Okay, so if the alternative, let's see. All right, so it says if HA is true, what's the probability of a type 2 error? Well, what does it say up here?
29%.
Type 2 error probability is 29%, so I'm going to put 0.29. If the alternative is true, what's the probability of a good decision, meaning you didn't make a mistake? What'd you say?
The power?
It's the power, yeah. So 71% chance that we did not make a mistake. That means we rejected the null, but we did not screw up. We did it right, okay? So probability of 0.71. All right. Now, there's a lot of technicalities in power that you don't have to know. All right, just trust here. I'm going to give you what you need, but there's a lot behind it you don't have to know. So what we have here is a curve based on what the claim is and a curve based on what reality is, right? And we're looking at the overlap. We want our power to be high because that means we're going to make a good decision. We're not going to screw it up, right, in our decision making. Higher the power, the better the research. Basically, better results. So if we interpret the probability of this good decision in the context of the problem, we would say that there is a 0.71 probability of finding evidence that Smith's free throw rate is 80%. So I'm just going to put in parentheses. We correctly we rejected the null. We just put that in context. That's all we did. We found evidence that his true free throw rate is really less than 80%. Okay, so what's shaded right now in this picture is the overlap, right? What we have it do now is shade in the power of the test. That's the strength of our test to get it correct, 0.71. All right, now, obviously we want power to be high. So how can we adjust our power? There's 3 ways you can adjust your power. So notice here, I'm going to play first with my sample size. So pay attention to what power is. It starts off at 71%, right? If I go to, let's go to 200. What did my power do?
It went up a lot.
Way up, right? So then, what do you predict is going to happen if I take my sample size way down? Way down. Boop. Yeah, lame. Don't do it that way, right? Always bigger samples. Always, always, always. So we want big samples because sample size will increase our powers. Let me get you back to 50. All right, so we can write that here. Sample size, if it goes up, let's see, increase the sample size, it increases the power. All right. Alpha. Alpha is what?
Type 1.
No.
No.
What is the alpha? It's called the significance level. It's also the probability of a type 1 error, right? Remember our default is 5% that we use all the time? Okay, so as a researcher, you can adjust your alpha. How specific do you want your results to be? So, at 5%, we see that power is 71. So let's jump it to 10%. What happened to our power? It went up. The reason is there's a bigger space, there's a bigger area under the curve that we could hit, right? So when we get into critical values, you're going to see that there's a bigger space that our values can fall in, which means we're more likely to do it, right? So alpha, if we increase alpha, we increase power. Just for fun, if I take that alpha and I take it way down to like 0.01, some researchers do that, look, my power goes way down. Okay, so it's a direct relationship so far, alpha and sample size. Alternative P. All right, what in the heck does that mean? That means the difference between this and this, what the claim is and what reality is. All right. So this is called, that difference is called effect size, just for fun. So we call it effect size. And it's like this: if I increase my alternative, let's see. Okay, so right now my alternative is 0.67, but the truth is 0.8, right? Which way do you want to go first? Closer to it or further away? Closer. So let's increase this to 75. It went down, right? It's harder to distinguish the difference when they're really close together, isn't it? Which makes sense. So what if I made his true free throw rate like 30%? It's going to be a real obvious difference. We're not going to screw that up, right? So effect size has to do with what is the reality versus the claim. If there's a big difference, then your power is going to go up. You're going to be able to tell that difference. But if it's really close, then there's a chance you might miss it, right? Kind of makes sense. Okay, so if effect size increases, our power increases. Isn't that nice? They're all the same way. Your job is to remember what effect size is. Difference between the alternative and the truth. Not bad, right? We good? Okay. Okay. So then, remember this little table we did before? Yep. All right, let's see what you remember. Type 1 error. What's the probability of type 1 error? Is what? Or in symbol form, it's alpha. Yeah. Usually it's 0.5. Yeah, right. 0.05. All right. So type 1 error is called this. Type 2 error is called beta. It's like a bee with a little tail on the backside. The probability to find that, it's not like you add alpha and beta together to get a 1 with probabilities. It's going to be, oopsies, 1 minus the power of the test gives me beta. All right? They will give you one of the two if you ever had to calculate it, but I don't think TW requires that. Okay. All right. So looking at our table, we now know that if we rejected the null and the null was false, that's a correct decision, but it's like we leveled it up and we called it power. This is now power. This other correct decision is a correct decision, it just doesn't have a specific name. Okay? All right, let's see. So I would say this. What is power? Power is the probability of correctly rejecting the null hypothesis. That's the easiest way I know to say it. All right, so then if you have to interpret it, here's an interpretation. If the alternative is true, there is your value of power probability of finding convincing evidence to reject the null. And then there's 3 ways we can adjust our power. What do we do to sample size? If we want to increase power, what do we do to sample size? Increase. If we want to increase it, what do we do to alpha? And distance to the alternative? Increase. All right. And this is called effect size. In higher academics, they call that effect size. All right. Alrighty, so let's try this out. It's really not that bad, honestly. Okay, a statistics major and a finance major decide to get married. In order to investigate their per-person expenses, they select a random sample of guests they have invited to the wedding and record whether or not each person plans to attend the wedding. They decide to test the null of P equals 75% against the alternative that it's not 75%. P is the true proportion of all the guests who will attend the wedding. The power of the test to reject the null when P is 70, using an alpha of 0.05 and a sample of 25, is 0.10. That power is low, right? Low. So it says to interpret the power. All right, so let's interpret this power. Oh, I know why this is. So, to interpret the power, if we use that sentence they gave us just for fun, because it's early. All right, if the alternative is true, that the proportion of guests who will not attend is not equal to 0.75, there is a 10% chance or probability of finding convincing evidence to reject the null, which says that the proportion would be 0.75. Okay? You won't have to do a lot of interpreting, I promise. Okay? Find the probability of a type 1 error and the probability of a type 2. Okay, so type 1 we know is just alpha. What is the alpha value for this scenario? Point what? 0.05, because it doesn't state anything else, right? So 0.05. Probability of a type 2 is called beta, and it's 1 minus the power. Well, what was the power? 10%. That's an easy subtraction, so it's a 90% chance of a type 2 error. Not good. And then lastly, determine whether each of the following changes would increase or decrease the power of the test. All right? So if I use an alpha of 0.01 instead of 0.05, is that going to increase or decrease my power? Decrease the power. That's like saying you got to have 100 eyewitnesses of a crime to convict. That's going to be really hard to do, right? It's possible, but it's really unlikely. All right, then what if we choose a sample of 100 instead of a sample of 25? Increase the power. There you go. Not so bad, eh?